Welcome to the Manage and Monitor Autonomous Database workshop. This is a quick demo that shows you a variety of ways to manage and monitor your Oracle Autonomous Database on shared infrastructure. So let's get started. First, we will provision a new Autonomous Database instance. The steps we will be doing now will apply similar to either Autonomous Data Warehouse or Autonomous Transaction Processing. This demo shows provisioning of an Autonomous Data Warehouse database. Once you log into your Oracle Cloud account, click the navigation menu. Click Oracle Database and then Autonomous Data Warehouse. Use the List Scope drop-down menu to select your compartment. You can find the compartment assigned to you on your reservation information page. Copy and paste the compartment name in the Search Compartments field to quickly locate your compartment. Make sure your workload type is Data Warehouse or All to see your Autonomous Data Warehouse instances. In this example, Data Warehouse is the workload type. This console shows that no databases exist yet. If there were a long list of databases, you could filter the list by the state of the databases, like available, stopped, or terminated. Click Create Autonomous Database to start the instance creation process. This brings up the Create Autonomous Database where you will specify the configuration of the database. Choose the compartment assigned to you. Enter a memorable name for the database for display purposes. For example, ADW_finance_mart. Give your database a name. For example, use ADW Finance. For this lab, choose Data Warehouse as the workload type. For this lab, choose Shared Infrastructure as the deployment type. Now let's configure the database. We are choosing 19C for this demo. Specify 1 CPU for your service. Keep autoscaling enabled. For this lab, we will specify 1 TB of storage to enable the system to automatically use up to 3 times more CPU and I/O resources to meet workload demand. There is no need to enable storage autoscaling, which would allow the system to append up to 3 times the reserved storage. Specify password for admin user for this database instance. Please check the password requirements in the Lab 1, Task 2, Step 7 of the workshop instructions. In the Network Access section, accept the default Secure Access from Everywhere for this lab. If the Require Mutual TLS, MTLS authentication option is selected, MTLS will be required to authenticate connections to your autonomous database. For this lab, leave the default. For more details about the other network access options, you can check the workshop instructions in Lab 1. Now choose a license type. For this lab, choose license included. Do not provide a contact email address in this lab. The contact email field allows you to list contacts to receive operational notices and announcements, as well as unplanned maintenance notifications. Click Create Autonomous Database. Your instance will begin provisioning. In few minutes, the status will turn from provisioning to available. All right, the database is provisioned. At this point, your Autonomous Data Warehouse database is ready to use. Have a look at your instance details here, including its name, database version, OCPU count, and storage size. Now let's explore the provided sample datasets that come with your Oracle Autonomous Data Warehouse instance using SQL Worksheet. From your ADW Finance Smart's database details page, click the Database Actions button. The Database Actions page opens for your admin user. In the Development section, click SQL. This is SQL Worksheet. This is a convenient browser-based tool offering a subset of the features and functions in Oracle SQL Developer. The first time you open SQL Worksheet, a series of pop-up informational boxes may appear, providing you a tour that introduces the main features. Click Next to take a tour through the informational boxes or close the tour. Now let's run a query on a sample Oracle Autonomous Database dataset. Copy and paste the code snippet from your workshop, Lab 2, Task 2, Step 1 instructions to your SQL worksheet. This query will run on the star schema benchmark ssb.customer, one of the 2 ADW sample datasets that you can access from any ADW instance. Take a moment to examine the script. Make sure you click the Run Statement button to run it in SQL Worksheet so that all the rows display on the screen. Take a look at the output response from your Autonomous Database Warehouse. When possible, ADW also caches the results of a query for you. If you run identical queries more than once, you will notice a much shorter response time when your results have been cached. You can find more sample queries to run in the ADW documentation. So far, we have used SQL Worksheet from Database Actions to access an autonomous database directly from the Cloud Console without a connection wallet. Now, we will connect Oracle SQL Developer desktop client securely to your autonomous database, both with and without a connection wallet. Download the latest version of Oracle SQL Developer from the link in the lab. From Lab 3, Task 1 for your appropriate platform. Simply download your appropriate platform zip file and unzip it into a desired parent directory or folder, and then double-click the executable file named sqldeveloper.exe to install and start SQL Developer. So first, let's see how to securely connect SQL Developer without a wallet using TLS connections. Refer documentation for detailed information on allowing TLS connections. Define an IP-ACL access control list. In the Autonomous Database Details page, in the Network section, click the Edit button next to Access Control List. In the Edit Access Control List dialog, you might normally accept the default IP notation of IP address and click Add My IP address, and your computer's IP address would be added as a value. However, for this lab that you might be running in any one of a variety of different environments, let's make a different selection. Open the IP notation type from the drop-down menu, select CIDR block. In the values field, enter the value 0.0.0.0/0. Click Save. Wait a minute for the database status to change from updating to available. In the Autonomous Database Details page, in the Network section, note that the access type has automatically changed from default access type that you used when provisioning the database. Allow secure access from everywhere to allow secure access from specified IPs and VCNs. Click the Edit button next to the Mutual TLS MTLS authentication. In the Edit Mutual TLS authentication dialog, deselect the checkbox that requires Mutual TLS MTLS authentication and click Save. Wait a minute for the database status to change from updating to available. When the update finishes, note that Mutual TLS MTLS authentication field has changed from required to not required. Now let's obtain the TLS connection string. In the Autonomous Database Details page, click the Database Connections button. The Database Connection dialog pops up. In the Connection String section, change the TLS authentication selection from Mutual TLS to TLS. This will enable SQL Developer and other applications to connect to your Autonomous database securely without a wallet. Choose one of the connection strings such as ADW_finance_hi. Then click Copy to copy that connection string. Paste the connection string to a notepad for your use in the next step. Then click Close to close the database connection dialog. Start the Oracle SQL Developer and in the Connections panel, click New Connection button. Enter a name for this connection such as Connection Without Wallet using TLS. Enter the database username. You can use the default administrator database account admin provided as part of the service or create a new schema and use it. In this demo, I'm just going with the admin as username. Enter the password you created for the database user. For the connection type, select Custom JDBC. For the custom JDBC URL, paste this jdbc:/oracle:/thin:@ followed by the connection string you copied. Click Connect to connect to the database. Now, in this another method, let's download and configure a connection wallet to securely connect SQL Developer to your Autonomous database. In your database instance details page, click Database Connection. Use the connection dialog to download client credentials. For the wallet type, in this lab, select Instance Wallet. This wallet type is for a single database only. This provides a database-specific wallet. Click Download Wallet. Specify a password of your choice for the wallet. You will need this password when connecting to the database via SQL Developer later. Oracle recommends that you provide a database-specific wallet using Instance Wallet to end users and for application use whenever possible. Regional wallets should only be used for administrative purposes that require potential access to all Autonomous databases within a region. Click Download to download the wallet file to your client machine. Once the wallet is downloaded, close the database connection dialog. Now let's connect to SQL Developer to database securely with wallet. Click the new connection icon in the Connections toolbox on the top left of the SQL Developer homepage. In the new database connection dialog, let's fill in the connection details. For the name, provide admin_hi. For username, provide admin. Specify a password that you used when provisioning your instance. For the connection type, choose Cloud Wallet. For the configuration file path, enter the file path for the wallet you downloaded by clicking on Browse and point it to the location of your file. For the service, there are 3 configured database services for each database. Pick the database name underscore hi for this lab, which is ADW finance underscore hi. I'm going to connect to the database by clicking the connect button. Now, query your autonomous database with SQL Developer. The SS schema provides a small dataset that you can use to run the sample queries in the database data warehousing guide. In a SQL Developer worksheet, copy and paste the query from Lab 3 Task 5 Step 1 and run the SH query. It shows you how the SQL function rank works. Now let's explore the monitoring capabilities available for your Oracle Autonomous Database. In your Autonomous Finance Smart Database details page, scroll down to the metrics section. The metrics section displays an initial set of 8 graphs: CPU utilization, storage utilization, sessions, execute count, running statements, queued statements, database availability, and failed connections. To examine the database metrics, the time period displayed on the metrics screen can also be easily changed to reflect the desired time period. Click the View All Database Metrics link to examine many additional graphs of data metrics like transaction count, current logons, user calls, etc., and many more. You can also view the monitoring information with more detailed tools provided in the Database Actions Launchpad. Go back to your Autonomous Database Details page, click Database Actions button. Log in as admin user. In the Monitoring section, click Database Dashboard. The database dashboard opens in the Overview tab. The page gives an overview of the storage allocation and usage, CPU utilization, running SQL statements, the number of allocated OCPUs, and SQL statement response time. By selecting the Monitor tab at the top of the page, you can also view this information in real time or in a specific time period. The Monitor tab opens initially in the real-time view. When you click the time period view, you can use the calendar to look at a specific time period. Now, you can view real-time and historical performance data from the Performance Hub. Performance Hub shows information about active session history, ASH, analytics, and SQL monitoring. On the Database Actions Launchpad, in the Monitoring section, click Performance Hub. The Performance Hub page displays. At the top of the page, you can select the time range to display, followed by the activity summary, which is displayed in database time in units of active average section. As we scroll down the page, you can view active sessions history, analytics, and SQL monitoring. The ASH Analytics tab shows you average active sessions. Click the SQL Monitoring tab. Each SQL statement can be inspected for further details. If you open the Performance Hub from the Autonomous Database Details page rather than from the Database Actions Launchpad, some additional information is available. From the Reports drop-down list, select Automatic Workload Repository. In the Generate Automatic Workload Repository Report dialog, select the Start Snapshot and End Snapshot time range. After you select the time range, click Download. Use the Save As dialog to specify where to download the report's HTML file to your local computer. Click the downloaded HTML file to view lengthy detailed report. Another way for monitoring your autonomous database is the OCI Monitoring Console. Click the navigation menu, click Observability and Management, and select Service Metrics. Make sure you are in the right compartment. Choose a metric namespace in the drop-down menu to the right of the compartment. Click the Edit symbol next to Dimensions. In the Edit Dimensions pop-up dialog, select Deployment Type. Click Done. The page updates to display only the resources in that compartment and namespace. Scroll down. It shows the metrics like CPU utilization, storage utilization, sessions, execute count, and many more. You can check workshop instructions for more details. In addition to the service metrics, you can also perform queries on the metrics by using Metrics Explorer, creating alarms, and creating health checks to ensure that users will become immediately aware of any availability issues. Now let's scale up your Oracle Autonomous Data Warehouse service to have more CPUs. Click on Navigation menu and go to your Autonomous Database Details page. Click the Manage Scaling button. In the Manage Scaling dialog, update your OCPU count to 8. OCPU autoscaling, we accept the default enablement of autoscaling. Keep the checkmark in this checkbox. Update the storage in terabytes to 2. For the storage autoscaling, keep the checkbox deselected. Click Apply after filling in the Manage Scaling dialog. The applications can continue running during the scale operation without downtime. On the Autonomous Database Instances Details page, a message will appear indicating scaling is in progress. Wait a few minutes for the scaling to finish. When scaling finishes, the message will change to Available. In the Lab 5 Task 2, there is a demo that shows the performance impact of scaling up your instance, and it also shows how you can dynamically scale up a database while the workload is running to increase the transaction throughput. Scaling up can also provide more concurrency for your users. Now let's see the benefits of autoscaling and Oracle Autonomous Database. This lab uses the existing SSP schema in Autonomous Data Warehouse. The business case we want to answer here is to summarize orders by month and city for customers in the US in the fall of 1992 over our benchmark SSB dataset containing 1 TB of data. For the test 1, with autoscaling disabled, you will have 3 SQL developer web sessions executing queries, sharing the OCPU and IO resources, and you will examine query times. Now go to the Autonomous Database Details page for your database. Click Manage Scaling. In the Manage Scaling dialog, deselect the OCPU autoscaling checkbox to disable autoscaling. Click Apply. This will close the dialog and return to your details page for the database. On the Autonomous Database Details page, wait a few minutes for the Scaling in Progress message to change to Available. Click the Database Actions button and log in as admin user. On the Database Actions Launchpad, click SQL Card. Now create and save 4 SQL Developer Web Worksheets. In SQL Developer Web Worksheets, you can choose a consumer group from drop-down menu in the upper right corner. Save the first worksheet with the name Setup. You will use this worksheet with the low consumer group to run the setup that creates a procedure for running test queries. The low consumer group is appropriate for non-CPU intensive tasks such as this creation of a procedure. Save the other 3 worksheets with the names Query 1, Query 2, and Query 3. Later, we will use these 3 worksheets to simultaneously run the test queries using the high consumer group. Note that when you reopen a saved worksheet, it opens by default with lower consumer group. If you want to run a script in the reopened worksheet using the higher consumer group, you need to manually change it from low to high. You can check the documentation for more details about consumer groups. Copy and paste the script in Lab 6, Task 2, Step 1, into the first worksheet you named Setup. Run the following script using the lower consumer group. Running the script will create a procedure, test_proc, for the workload used in the test. When this procedure is executed, it will run a query in a loop of 2 times to answer the business case from our SSP database. Also, it creates a sequence used for each test number and creates the table used to save the results. Now, open 3 worksheets you named Query 1, Query 2, and Query 3. To open 3 SQL Developer Web Worksheets, simply go back to the OCI Console's details page for your database. Click the Database Actions button, and in the Database Actions Launchpad, click SQL Card to open the SQL worksheet. We will be doing this 3 times so that you have 3 SQL worksheets open in your browser. In the first SQL worksheet, select your saved Query 1. In the second worksheet, select your Query 2. In the third worksheet, select Query 3. Make sure that each of the 3 worksheets are set to high consumer group. Copy and paste the test_proc command in each of the worksheets, but do not run immediately these commands in each of these worksheets. After you have entered the command in all the 3 worksheets, quickly execute the command in each worksheet so they all begin nearly at the same time. While the 3 procedure instances are running concurrently, this test runs for approximately about 4.5 minutes on a 1 OCPU count. While the 3 procedure instances are running concurrently, go to your Autonomous Database console page and click Performance Hub. In the Performance Hub, click SQL Monitoring tab and look at the monitored SQL to see that each worksheet is running your procedure. Make sure all the 3 tests in the worksheets indicate that the queries have executed completely. You can see if the test procedure is still running, or completely successfully, or failed in the worksheet status at the bottom of the page. Navigate back to your setup worksheet. Run the script in Lab 6. Note that the value CPU count displays 2 times the number of OCPUs available, as each OCPU has 2 CPU threads. Thus, 1 OCPU we see CPU count of 2. As part of test 2, you will enable autoscaling again, and have 3 SQL developer web sessions executing queries. Autoscaling will allow your running sessions to use up to 3 times more OCPUs, reducing your execution times significantly. So go back to your autonomous database details page, click Manage Scaling, and select the OCPU autoscaling checkbox to re-enable autoscaling. Enabling the autoscaling allows you to use 3 times the amount of base CPU and I/O. Once again, go to your 3 SQL developer web query worksheet instances which are using the high consumer group. Just like how we did earlier, run the exec test_proc command in all the 3 worksheets quickly so that they begin at the nearly same time. While the procedures are running, the monitored SQL in Performance Hub shows 3 queries executing. Go back to your SQL Developer web worksheets to be sure all 3 tests in the worksheets indicate that the queries have executed completely. When the procedures have completed, run the script in Setup worksheet to see the test results and examine the improved performance after enabling autoscaling. These numbers look great. As part of test 1, we had autoscaling disabled, and as part of test 2, we had autoscaling enabled. After enabling autoscaling, we see that the number of OCPUs available to the database jumps by 3 times. All 3 running sessions now had access to 3 times the amount of CPU and I/O. Consequently, the average query time reduced, and therefore, the duration of total tests that ran part of 3 worksheet sessions concurrently reduced, approximately 3 times. Go to your Autonomous Database console page and click Performance Hub. Move your cursor in the Activity panel above the SQL Monitoring panel and drag the rectangle horizontally across to cover the portion of the timeline that indicates your recent query activity. This will fill in the SH Analytics panel at the bottom with the information from the completed test. Scroll down and view the average active sessions chart. View the average active sessions chart by weight class in the second test after autoscaling is enabled. Since there are 3 times OCPUs available to the running queries, we now see the inflated I/O weights in blue due to unavailability of resources reduces significantly. Consequently, the workloads become more efficient, CPU bound, and is able to utilize more CPU, reducing the average time spent on running each query. The scheduler waits on CPU I/O resources almost entirely disappears. You can refer the workshop instructions for more details in the Lab 5 Task 6 Step 4. As we are running this workshop in a Live Labs hosted sandbox, let's change the scaling values back to original setting of 1 OCPU and 1 TB of storage to enable the lab on activating disaster recovery using data card to have sufficient resources. Now let's take a look at 2 types of disaster recovery features in Autonomous Database on shared infrastructure. In this demo, we will practice enabling the Autonomous Data Guard using a standby database. Then, you can learn about backup-based disaster recovery, which uses a backup copy of your primary database in the Lab 7 Task 4. On your Autonomous Database Details page, scroll down to the Resources section and click Disaster Recovery. Note that the display of your local backup copy, that is one of your database's automatic daily backups. This is not a physical standby database, but simply a backup copy stored from the source, which is a primary database, which can also be used to instantiate a new database at the same time of switchover or failover. We want to enable Autonomous Data Guard, which will create a standby database, a replica of the primary database, which will constantly and passively refresh, that is, replicate data from the primary, which can be used in case of failure of the primary. To do so, click on the 3 dots, which is ellipsis symbol on the right side of the backup copy, and select Update DR Type. The Update Disaster Recovery Type dialog appears. The Backup Disaster Recovery button is selected by default. Instead, select the Autonomous Data Guard button and click Submit. The Autonomous Database Lifecycle state changes to updating. Depending upon the size of your primary database, this may take several minutes. Note that while you provision a new standby database, the primary database is available for read and write operations, enabling Autonomous Data Guard in non-blocking. There is no downtime on the primary database. While the standby database is provisioning, observe the status in the database details page, disaster recovery section. The prior role column still indicates the backup copy, and the DR type column is still indicating that the disaster recovery type is backup based. The state field indicates that the Autonomous Data Guard standby is provisioning. When the standby database finishes provisioning, observe the peer role column has changed from backup copy to standby. The state column has changed from provisioning to standby, and the DR type column has changed from backup base to autonomous data guard. You can create a copy of two standby databases, one local and the other cross region. You just enable autonomous data guard to create a local standby database. If your Oracle Cloud account has at least two regions, you can optionally create a second standby database that is cross region. As we are running in Live Labs hosted sandbox environment, the cross-region standby databases are not yet supported. To perform the optional step of adding a second standby database that is cross-region, you could have done by clicking the Add Peer Database. If that database was added as well, at this point, you will have three autonomous data warehouses databases, which is the original ADW Finance, the local standby database, also named ADW Finance, and the optional cross-region standby database, which could have been like autonomous database underscore remote. Go back to your autonomous database details page of your original database. In the autonomous data guard section of the database, you now see a third field, region. This page indicates you are in your original database, ADW Finance, with the role of primary database in the primary region. After autonomous data guard is enabled, if you perform a switchover operation, the primary database becomes the standby database, and the standby database becomes the primary database with no data loss. A switchover is typically done to test your application's failover procedures when autonomous data guard is enabled. To perform a switchover to the local standby database, on the details page of your original primary database under disaster recovery, in the role field, click switchover. Confirm switchover to peer dialog. Select your standby database, your local standby, not the remote cross-region standby if you have created one. Enter the database name of your local standby and click confirm switchover to peer. The database lifecycle state changes to updating and the state field shows role change in progress. Then the state field of both your local and remote standby databases will show provisioning. Eventually, the state field for your standby will show standby. When the switchover operation completes, the primary database goes into the available state and can be connected to for queries and updates. The peer state field will change to available when the standby is ready. You can see the time of the last switchover when you hover over the tooltip icon in the disaster recover role field. You can also optionally switch over to your remote cross-region standby database if you have created one, but in case you will switch over from the remote standby rather than from the primary. Please note that if you're running this workshop in a Live Labs hosted sandbox environment, cross-by region standbys are not yet supported in Live Labs environment. Now let's disable autonomous data guard. As we are running this workshop in a hosted Live Labs sandbox, you must perform this task to free up resources for the next lab on creating refreshable clones. On the autonomous database details page, in the disaster recovery section, for each standby database you created, click the three-dot ellipsis symbol on the right side of the standby and click Disable Peer to disable the autonomous data guard. In the Disable Disaster Recovery dialog, select the standby database that you want to disable and terminate. Enter the autonomous database name to confirm that you want to disable autonomous data guard for the instance. Click the Disable Disaster Recovery. Note that if your autonomous data guard is enabled with both a local standby and a cross-region standby, you disable autonomous data guard individually for the local standby or the remote standby. If there is only one local standby or only a remote standby, you have one choice. The database lifecycle state changes to updating and the state field changes to terminating. Note that disabling autonomous data guard terminates the standby database. If you later enable autonomous data guard, the system creates a new standby database. If you switched over to remote cross-region standby, you must switch back to the primary region before you can disable the cross-region standby. One of the most widely used features in autonomous database on shared infrastructure is the ability to clone your database, no matter how big or small, with little to no effort. Let's see how to create a full clone from the currently running database or from a backup timestamp of that database. To create a full clone database from your currently running primary database, navigate back to your autonomous database details page of your source database. From the More Actions drop-down menu, click Create Clone. The Create Autonomous Database Clone dialog appears. Choose a clone type, accept the default full clone. For clone source, note that the default selection is clone from database instance. Let's provide the required information to create the clone database. The preferred region by default is your current region. Provide a display name and a database name. Fill in the rest of the screen as you did, just like how we provisioned an autonomous database initially. And click Create Autonomous Database Clone. When the clone finishes provisioning, check the clone information in the autonomous database details page. Now create a full clone database from a backup timestamp of your currently running primary database. Return to the autonomous database details page of your source database. From the More Actions drop-down menu, select Create Clone. The Create Autonomous Database Clone dialog appears. For the Choose a Clone type, accept the default Full Clone. For Clone Source, note that the default selection is Clone from Database Instance. Instead, select Clone from a backup. In the Backup Clone area, you can choose a point-in-time clone, select the backup from a list, or simply choose the latest backup timestamp. In this case, I am choosing Select the backup from a list. Choose one of the backups to create the clone from the list of backups that appear on your screen. Backups are created daily. Provide the required information to create the clone database as we did before. The preferred region is by default your current region. Provide a display name and a database name. Fill in the other sections as we did earlier when provisioning the autonomous database instance and click Create Autonomous Database Clone. When the clone finishes provisioning, check the clone information in the autonomous database details page. Now let's create a long-term backup. In today's world, regulations, audits, and compliance requirements often demand long-term retention of data. It is essential to have a database backup plan that covers both short-term and long-term retention. As with other aspects of Oracle Autonomous Database, the process of long-term backups is completely automated and managed by Oracle. So let's go ahead and see how that is created. Scroll down the Autonomous Database Details page for your database and select Backups under the Databases Resources section. You will see the Create Long-Term Backup button. The Create Long-Term Backup dialog appears. In that, provide when you would like a long-term backup to be taken, immediately or at a scheduled time in future or repeatedly at your preferred cadence. And also how long you would like us to keep a long-term backup for you. That is the backup retention period. While your existing automatic backups have a backup retention period of 60 days, long-term backups can be retained starting from 90 days all the way up to 10 years. You may also automate long-term backups at your own. Personalized cadence by calling long-term backup CLI APIs in your scripts or via Terraform. Click Create. When you click Create, Oracle starts an asynchronous job to create a long-term backup for you in the background, so your database is not held up waiting for the backup to complete. You can track this long-term backup and other lifecycle management operations triggered on your database by clicking the Work Request tab. When your long-term backup is available, you will see it in your list of backups. Each long-term backup is a standalone backup that can be managed individually. You may edit the retention period of a long-term backup, delete it if you no longer need it, or clone from a backup when you need an instantiated database copy from that long-term backup. It is good practice to test your long-term backup after creating it by cloning from it to ensure your backend data is as required. From the Autonomous Details page, you can view the details of any scheduled long-term backups and you can edit a long-term backup schedule. So far, we have seen how to create a full clone from the currently running database or from a backup timestamp of that database. Now let's see how to create a refreshable read-only clone that automatically refreshes when the data in its source database changes. Navigate to your existing ADW Finance Smart database instance that you created. In the Autonomous Database Details page of the OCI console, connect to Database Actions as the admin. On the Database Actions launchpad, under the Development heading, click SQL. Create a table named Refresh Clone Test with a single row of data in it before you proceed to clone the database. In the worksheet, note the time that you perform this action. Now that you have created a table in the source database and populated it with a row of data, you will create a refreshable clone from the source database. Return to the Autonomous Database Details page of your source database. From the More Actions drop-down menu, click Clone. Select the Refreshable Clone option. A refreshable clone must be refreshed every 7 days or less. Otherwise, it falls too far out of sync from the source and can no longer be refreshed. For this lab, name your clone's display name and database name as Refresh Clone. Select the number of OCPUs for your refreshable clone. There is no storage selection necessary, since this is a read-only clone that only brings in data from its source database. The amount of storage selected in TB is automatically the same as that of the source. There is no admin password option for the refreshable clones as well, as that is taken from the source when refreshed. Select the license type and click Create Autonomous Database Clone. Once the clone is provisioned, you can see useful clone information on the OCI console, including the source database that the clone is attached to, and the refresh point timestamp of the source from which the clone was refreshed. Open the database actions SQL worksheet from the refreshable clones OCI console and query the database with select star from refresh clone test. It shows a table refresh clone test that you created in the source with the single row of the data that you inserted. You've proven that the refreshable clone contains the source databases table with one row of data. Now add a single row of data to the source and see how to refresh the clone to pick up that second row. Switch back to the sources or database actions SQL worksheet. Insert and commit an additional row in the source database. You now have two rows in the source, but only a single row in the refreshable clone. Make note of the time when you inserted the second row. Now see how easy it is to refresh the clone with the new data you just added to the source. Return to the database details page of your clone database. Click the refresh button in the banner. This banner also displays the date and time before which you must refresh the clone, which is 7 days after the last refresh was performed, before it would lose the ability to sync the date with the source database. The refresh clone pop-up dialog asks for a refresh point timestamp of the source database to which you want to refresh. Let's say if you have inserted the second row in the source at 17:59 p.m. UTC, you could input as 18 p.m. UTC as your refresh point. So please provide the refresh time as and when you have inserted the second row. After you enter your refresh point timestamp, click Refresh Clone. While the clone is refreshing, it enters the updating state. During a refresh, connections are not dropped and any running queries on the clone simply wait until the refresh is completed. The refresh may take several seconds to several minutes depending upon how long it has been since last refreshed and the number of changes that have come in since then. Once the refresh is completed, you can see exactly what timestamp of the source the clone has been refreshed to in the clone's database details page. In the clone's database actions SQL worksheet, run the select query on the refresh clone test table, and instead of a single row, you now see both rows of the data from the source. The data in the clone has been seamlessly updated to reflect that what was in the source. With the refreshable clones feature, you can now keep cloned databases updated without any tedious manual export process. As new data comes into your source database each day, it can easily be refreshed into all its connected refreshable clones with a few button clicks. Moving on to the next topic, OCI notification service. It is not supported in the Live Labs hosted sandbox environment. As we are running this workshop in a Live Labs sandbox, you can view the steps in Lab 10 to learn about setting event and alarm notifications. However, please do not attempt to perform those steps. Now let me introduce you to the feature of Oracle Data Save. You will prepare your environment in Oracle Cloud Infrastructure for this lab by registering your autonomous database with Oracle Data Save and discover sensitive data. As we are running this workshop in Oracle Live Lab Sandbox environment, user group and policies are already added for the user group. Let's load some sample data into your database. From Lab 11, Task 3, download load data save sample data underscore admin SQL script and open it in a text editor such as Notepad. To do so, navigate back to your database details page and click the database actions button. As an admin user, from the database actions launchpad in the development section, click SQL. Copy the entire script to the clipboard and paste it in the worksheet. The last line of the script would be as select null as end of script from 12. Click the Run Script button from the toolbar and wait for the script to finish. The script takes a few minutes to run. In the bottom left corner, the cog wheel may remain still for about a minute and then it turns as the script is processed. The script output is displayed after the script is finished running. Don't worry if you see some error messages on the script output tab. These are expected the first time you run the script. The script ends with the message end of script. To ensure the sample data is loaded successfully, at the end of the script output, review the row count for each table in the HCM1 schema. The count should be as like countries 25 rows, departments 27 rows, etc. Now, refresh database actions in the browser page and then verify that the HCM1 schema is listed in the drop-down list of the navigator pane. To use a database with Oracle Data Save, you first need to register it with Oracle Data Save. A registered database is referred to as target database in Oracle Data Save. After registering an autonomous database, you can grant and revoke roles from the Oracle Data Save service account on your autonomous database to control which Oracle Data Save features you can use with the database. You need to register your autonomous database before granting roles because registration unlocks the Oracle Datasafe preceded service account on your target database. For an autonomous database on shared Exadata infrastructure, which is what we are using as part of this demo, all Oracle Datasafe roles are granted by default during registration, except for data masking role. Navigate to the autonomous database details page, scroll down the page, and then under Datasafe, click Register. In the Register database with Datasafe dialog box, click Confirm. Wait for the registration process to finish for the status to change to registered. From the navigation menu, select Oracle Database and then Datasafe. The overview page for the Oracle Datasafe is displayed. On this page, you can access Security Center, register target databases, and find links to other useful information. On the left menu, click Target Databases. Make sure you're in the compartment assigned to you. A target database with an active status means that it is currently registered with Oracle Datasafe. In case if there is a target database with deleted status, means that it is no longer registered with Oracle Datasafe. The listing is removed after 45 days. Click on the name of your target database to view its registration details. On the target database details page, you can view or edit the target database name and description. You can also view the Oracle Cloud Identifier, which is OSID, when the target database was registered, the compartment name, to where the target database was registered, the database type, and the connection protocols like TLS. The information varies depending on the target database type. You have options to edit connection details, change the connection protocol, move the target database registration to another compartment, deregister the target database, and add tags. Data discovery helps you find sensitive data in your target databases. You tell data discovery what kind of sensitive data to search for, and it inspects the actual data in your target database and its data dictionary, and then returns to you a list of sensitive columns. By default, data discoveries can search for a wide variety of sensitive data pertaining to identification, biographic, IT, financial, healthcare, employment, and academic information. Start by examining sensitive data in one of the tables on your target database by using Oracle Database Actions. Then we will use Oracle Datasafe to discover sensitive data on your target database and generate a sensitive data model that lists sensitive columns in your target database. To do so, in the breadcrumb at the top of the page, click Datasafe. On the left under Security Center, click Data Discovery. Make sure you are in the right compartment. A data discovery dashboard is displayed with statistics for the top 5 target databases in your compartment. Your dashboard is most likely empty because this is the first time you are using data discovery in this workshop. Click Discover Sensitive Data. The Create Sensitive Data Model page will be displayed. On the Provide Basic Information page, in the name box, enter SDMV1. Make sure you are in the assigned compartment. In the description box, enter Sensitive Data Model 1. Select your target database and click Next. On the Select Schemas page, leave Select Specific Schemas only selected. Scroll down and select the HCM1 schema and then click Next. On the Select Sensitive Types page, expand all of the sensitive categories by moving the Expand All slider to the right. Scroll down the page and review the sensitive types. Notice that you can select individual sensitive types and sensitive categories and all sensitive types at one time. At the top of the page, select all checkbox and then click Next. On the Select Discovery Options page, select Collect, Display and Store Sample Data and then click Create Sensitive Data Model at the bottom of the page to begin the data discovery process. Wait for the sensitive data model to be created. The sensitive data model details page is displayed. Review the information on the sensitive data model details page. The sensitive data model information tab lists the information about your sensitive data model, including its name, the OSID, the compartment to which you saved it, the date and time when it was created and last updated, the target database associated with it, and many more. You can click the View Details link to view the work request information. The pie chart compares the number of sensitive values per sensitive category and sensitive type. The sensitive columns table lists the discovered sensitive columns. By default, the table is displayed in flat view format. For each sensitive column, you can view its schema name, table name, column name, and many more. Review the sample data to get an idea of what it looks like. Position your mouse over the identification information category in the chart to view its value. Your percentage value may be different than the value you see here on the screen. With your mouse still over the identification column information, click the pie slice to drill down. Note that the identification information category is now divided into two smaller categories, personal identifiers and public identifiers. To drill up, Click the All link in the chart's breadcrumb. Under Sensitive Columns, from the drop-down list, select Sensitive Type View to sort the sensitive columns by sensitive type. By default, all items are expanded in the view. You can collapse the items by moving the Expand All slider to the left. From the drop-down list, select Schema View to sort the sensitive columns by table name. If a sensitive column was discovered because it has a relationship to another sensitive column as defined in the database's data dictionary, the other sensitive column is displayed in the parent column. For example, manager ID in the department table has a relationship to employee ID in the employees table. All right, we have successfully completed the workshop. Thanks for watching.